Welcome to This Explainer. Today, we're diving into the totally fascinating anatomy of sparkling wine. We're going to demystify the journey from a rather flat, simple baseline to that glorious, bubbling celebration we all love. I am absolutely thrilled to guide you through this because, honestly, understanding the science behind what's actually in your glass, it completely transforms the whole tasting experience. We all recognize the beautiful, steady pour of a standard still wine. It's elegant, right? Full of complexity. But what happens when we want to take that flat, calm liquid and turn it into a lively, effervescent experience that literally dances on your palate? Well, that brings us right to the fundamental question we're answering today. How exactly do those magical bubbles get in there in the first place? As we're about to see, it's actually this brilliant combination of chemistry, meticulous engineering, and centuries-old tradition. Okay, here's our roadmap for today. We'll start with the magic of bubbles, craft the base wine, explore the traditional tank and transfer methods, look at industrial wine gasification, and end with a global celebration. Let's jump right into section 1, the magic of bubbles. While carbonated wines have this incredible, long history famously anchored in the Champagne region of France, today they represent a massive, thriving global industry. Think about it. We have Spanish cava from Catalonia, fresh Italian Prosecco from the Veneto region, and that beautifully mineral-driven German sect from the Mosel River Valley. These famous varieties haven't just created jobs and boosted wine tourism, they've become literal international symbols of luxury and prestige. But here's the crazy part. No matter where they're from, they all start out in exactly the same way. And that brings us to section 2, crafting the base wine. Before we can even think about bubbles, we have to establish the foundation. Now, the underlying analytical data reveals some highly counterintuitive chemistry. To make a great sparkling wine, you don't actually start with a perfectly balanced still wine. In fact, a great base wine needs a surprisingly lower alcohol content, usually between 9.5% and 11.5%, and very, very high acidity, with a pH dropping somewhere between 2.8 and 3.3. Basically, the big secret to success here is making a rather harsh, highly acidic, flat wine. To do this, grapes are typically hand-harvested early. Winemakers use varieties you probably know, like Chardonnay and Pinot Noir in France, Macabeo in Spain, or Glera in Italy. They employ short macerations to make sure there's very little color, low oxidation, and absolutely no tannins. That moderate alcohol leaves room for proper foaming later on, and that intense acidity, well, that guarantees a vibrant freshness on the palate once the carbonation is finally added to the mix. All right, moving on to section 3, the traditional method. This is the absolute gold standard of carbonation. Let's break down how this builds through 5 incredibly meticulous phases. First up, we have that acidic base wine we just talked about. Then they add a mixture of yeast and sugar. This is called the liqueur de tirage, and the wine is immediately bottled and sealed tight. Now, step 3 is where the real magic happens. A second fermentation takes place entirely inside that horizontally stored bottle. The yeast eats the sugar, and as a byproduct, it produces alcohol and, critically, carbon dioxide. Because the bottle is perfectly sealed, that carbon dioxide has nowhere to go. It dissolves directly into the wine, creating the immense pressure necessary for our bubbles. This step really highlights the sensory romance of the whole process. Step 4 is called aging on lees. This is where the wine just rests in contact with the dead yeast sediment. It sounds a little unappetizing, I know, but it develops incredible aromatic complexity and super rich flavors. But obviously you can't drink cloudy yeast sediment, so they perform what's called riddling, slowly and carefully tilting the bottle day by day to gather all that sediment right in the neck. Then comes disgorging. They literally freeze the neck of the bottle, uncap it, and boom, the bottle's own internal pressure shoots that frozen sediment plug right out. Finally, they top it off with a touch of sweetness called the liqueur d'expedition, pop a cork in it, and it's ready to go. Now, what if a winemaker wants a fresher flavor profile? Or maybe they need a more scalable, affordable process? Let's take a look at section 4, tank and transfer methods. Comparing these methods head-to-head really highlights why this matters to you as a consumer. The traditional method, as we saw, yields complex, bottle-aged wine, but it definitely comes with a higher price tag. The Charmat method, on the other hand, skips the individual bottles for that second fermentation. Instead, the base wine, yeast, and sugar are all mixed together inside massive, pressurized stainless steel tanks. The bubbles get trapped right there on the tank, the wine is filtered in bulk to remove the yeast, and then it's bottled under pressure. This is exactly how Prosecco is made, by the way. It preserves a really fresh, fruity profile, and it drastically lowers the cost.
Now, there's also this really clever hybrid approach known as the transfer method. It starts out exactly like champagne, fermenting inside the individual bottles so you get that high-quality bubble structure and great yeast contact. But instead of that painstaking individual freezing and disgorging process we talked about earlier, the wine is simply emptied out of the bottles into a large pressurized tank. From there, it's bulk filtered to remove the sediment and then rebottled into fresh bottles. It beautifully simplifies the whole operation, minimizing costs while still maintaining fantastic quality. A real win-win.
Next up, let's step away from natural fermentation entirely. Here's Section 5, Industrial Wine Gasification. This highly engineered system completely bypasses yeast and sugar. Instead of letting nature slowly create the carbon dioxide, complex industrial columns and pumps are designed to inject CO2 mechanically straight into a pressurized stream of still base wine. These machines achieve this rapid gasification in 3 primary ways. First, constant pressure machines apply a uniform blanket of CO2 into a pressurized tank of wine through a diffuser. Pretty straightforward. Second, needle gasification machines use ultrafine needles perfectly submerged into the liquid to release precise little bubbles directly into the wine. And third, continuous flow machines actually inject CO2 into the base wine as it's actively being pumped through specialized chambers and pipes. This makes it a highly continuous, massive volume operation. It is important to note that while this method is an incredibly efficient engineering feat, it really is a purely mechanical shortcut. The winemaker is essentially just turning a dial to add fizz. For this reason, these gasification machines are absolutely never used for high-quality sparkling wines made in the traditional or even the Charmat manner. This process is strictly reserved for different high-volume tiers of commercial wine where sheer efficiency is the primary goal. Which brings us to our final section for today, a global celebration. We've seen how carbonated wine has evolved from its prestigious origins in Champagne into a truly diverse global industry. Understanding exactly how your wine gets its effervescence, whether that's through years of careful bottle aging, a fresh tank fermentation, or precise mechanical injection, really empowers you to look past the marketing on the label. You can start to truly appreciate the texture, the flavor, and the specific craftsmanship of exactly what you are buying. So, armed with this new knowledge of the anatomy of a bubble and the incredible journey from a flat, highly acidic base wine to a masterpiece of effervescence, I want to leave you with this. What style of sparkling wine will you choose to pop at your next celebration? Thank you so much for joining me on this explainer, and cheers!